Hello guys, welcome to another video on linear momentums. Previously we explored the fundamentals of linear momentums where we solve and analyze some worked examples. Today we would like to take it from there and dive deeper. If you are joining us for the first time, please do it to click on the subscribe button. Thank you. And as well, you can check the descriptions of this video to click on the link to the previous video. I am Ominka Favourable, your favorite online tutor. Today our lesson outline is solve simple problems based on Newton's law of motions. Lesson outcomes is after the lesson you should be able to calculate basic questions relating to Newton's laws of motions. Question 2. An object of mass 1 kg falls a distance of 5 meters on a horizontal surface and rebounds to a vertical height of 2 meters. Calculate the change in momentum. This is an illustration of the questions above. Say that the object is at this mass and the object is at a height of 5 meters above the ground level. So at this particular height, the initial velocity is equal to 0. And as the object is being released from this particular height, as it comes down, the acceleration due to gravity is positive because the object is falling under the influence of gravity. However, as it rebounds at 2 meters in the vertical height, it goes up, is going against the force of gravity. And as it's going against the force of gravity, the acceleration due to gravity is negative, and the final velocity is equal to 0. So this is an illustration. As it comes down, it's falling under the force of gravity, then it's going against the force of gravity as it rebounds. From Newton's third equations, velocity v of an object on reaching the horizontal surface is given by v squared is equals to u squared plus 2gh. That is because the acceleration due to gravity is positive. Where v is unknown, then the u is equal to 0, as we have earlier said. G is always given to be 10 meters per second squared. H is equal to 5 meters. Substituting u is already equal to 0, so the equation reduces to v squared is equals to 2gh. Substituted into this expression, you have it to be 2 times 10 meters per second squared times 5 meters. Multiply all of this, you have it to be 10 times 2 is 20, then times 5, you have it to be 100 meter squared per second squared. Then we are interested in finding the final velocity, so you take the square root of both sides. Take the square root of v squared, then the square root of 100. So the square root of this, take the square root of this, you have it to be v is equals to 10.0 meter per second. At maximum height, after rebounding, the velocity of the body is 0. That is, at this maximum height, the velocity of the object or the body is 0. Let the velocity with which it leaves the floor be u. That is, the initial velocity when it leaves this floor is let it be u. Hence, it is given by v squared is equals to u squared minus 2gh. Here is negative because the object is going up against the force of gravity. Therefore, the acceleration due to gravity is negative, as we have earlier said. Where h is equals to 2 meters, v is equal to 0. That is, the final velocity is equal to 0. Therefore, if you solve this, you have it. If you make v squared the solution of the formula, you have it to be v squared is equals to 2gh. Substituting into this expression, have it to be 2 times 10 meters per second squared times 2 meters, all is equals to 40 meters squared per second squared. Then take the square root of both sides. You take the square root of both sides, you have it to be u is equals to 6.32 meters per second squared. Therefore, the change in momentum, as we have earlier understood from our previous video, said that mv minus mu, where mv is the final momentum, then mu is the initial momentum. The momentum of the object hitting the floor is taken as positive, whereas momentum on moving away from the floor is taken as what? Negative. That is because momentum is a vector quantity and is being represented in magnitude and in directions. Hence, the change in momentum is equals to mv minus the initial momentum. Now is when the object rebounds up, so it's going to be negative. That is why we have m minus mv in a bracket here, where m is equals to 1 kilograms, v is equals to 10.0 meter per second, u is equal to 6.32 meter per second. Substituting change in momentum is equal to mv minus times minus is what? Positive, plus. So we have mv plus mu. So in this case, we can factorize m out. So we have m here. mv divided by m, we are left with what? V. We write it in a bracket. mu divided by m, you're left with what? U. We write it in a bracket. So we factorize m out. So now, substituting into this, now have it to be 1 kg into bracket 10.0 meter per second plus 6.32 meter per second, all in bracket close. So if you sum this and sum this, you have it, your answer to be 16.32 kilogram meter per second, or 16.32 newtons seconds. Thank you. However, you have a self-text 2 said a ball of mass 200 grams falls a distance of 9 meters on a horizontal surface and rebounds to a vertical height of 3 meters. Calculate the change in momentum if the object is in contact with the horizontal surface for 0.1 seconds. What is the force exerted on the body? Take the g, acceleration due to gravity, to be equal to 10 meters per second squared. Hint: if you solve this, you're able to arrive at the answer to be the change in momentum is equal to 42.34 kilograms meter per second, and the force exerted will be 423.4 newtons. Thanks for watching. Please do well to subscribe to the channel, and as well to comment and drop any mathematics and science related questions.